Anyways, my name is Arno Kolster. I'm a senior database architect at PayPal. I'm also an HPC User Forum Steering Committee member, one of the newer ones. Thank you very much for that honor. And I'm also on the HP Vertica Client Advisory Board. Ryan and I are here to talk not as much about PayPal itself, but a little bit more about enterprise and HPC and how we see some of the things converging in the future. So this talk basically came about because in 2012, when I first did a talk with you guys about PayPal's use of HPC in fraud detection, there's a lot of interest shown by some of the members about how we can collaborate with some of the things that PayPal is doing with HPC. And out of that collaboration came some work with Oak Ridge, especially Susie, who invited us to do a co-sponsored Birds of a Feather at Supercomputing 13. And that was very successful. We had some industry members on a panel, and we talked about HPC and enterprise, and it was well received. And in the same vein, we applied for a Birds of a Feather in Supercomputing 2014, which was also accepted. And so we did one in 2014 around technologies in HPC and big data architectures. And we had Steve Conway from IDC help moderate that session. He enjoyed it so much that he thought that it would be good if we recap that whole Birds of a Feather session in this particular talk. So that's the history of this talk and why we're doing it. So there's nothing about PayPal with HPC technology. It's more about how we're noticing trends in the industry and how Ryan and I have been straddling an enterprise and an HPC kind of gap, and we're trying to merge the two technologies together. So the main focus for the Birds of a Feather was around coming up with two hypothetical problems that we posed to the audience at the Birds of a Feather. It was kind of funny because we posed these two problems to the audience, and many of them thought they were realistic problems. And unfortunately, they weren't realistic problems, but these are problems that we do see can exist. So the first problem that we posed was around a network. Basically a large graph database that's kept up to date in real time, and we call it our network. For instance, it wasn't a PayPal network of financial media or social media. It was basically around any large-scale network that needs real-time inputs and real-time outputs. So for instance, the Ebola talk that we heard about earlier is a perfect example of this. You've got this simulation happening, but there's no way of doing real-time inputs and real-time outputs of what's actually happening to that network of simulated epidemic. And so that's one of the things that we wanted to bring to the HPC community, is saying we've got this large-scale network of a graph database, if you will, but we need to have inputs and outputs in real time to make any sense of it. And we see a lot of these examples, both in some of the things we saw today, as well as some of the things that we see in the enterprise world, where this is going to be happening. The second example, hypothetical example that we came up with was we call our world, which is basically if we took all the large data sets in the world, including weather systems, demographics, oceanography, all sorts of different large data sets, and melded them all together, and we're able to do real-time inputs and outputs on those, we would be able to do some really, really fantastic things around that. But there's no enterprise and there's no HPC consortium that can actually meld all those large data sets together and have the ability to do real-time analytics on those systems. So we posed these two problems out to the audience, and for 90 minutes we discussed them back and forth. It was very, very fruitful, very, very interesting. So what happens is, from the enterprise perspective, from the HPC perspective, you guys in the room that are HPC here excel at a number of different things. The first one is you'll take any problem that comes along. If you want to simulate Ebola, yes, we'll simulate Ebola. If you want to simulate wheat genomes, yes, we'll figure out wheat genomes. You'll take any problem that comes along because it's really exciting and it's something that you're really good at. You're not just good at adopting, you're also good at actually using the technology that's available to you. New hardware, new software, new paradigms in thinking about how to do compute. You're very good at doing that. You also push the performance envelopes on a number of different areas. For instance, you don't care if you have thousands and thousands of cores. Enterprise shies away from that. We're very used to just commodity hardware, but HPC community really likes to go after the larger data sets and larger compute horsepower, and you're not afraid of doing that at all. You also like parallelism, both CPU, coding, all those paradigms. You don't mind doing parallel programming. Enterprise shies away from that too. And of course, in collaborating, just look around. You've got people that you've known for years and years that you've collaborated with between different universities, different science communities, and also with enterprise customers like us. It's a great collaboration, organization, and mechanism for sharing ideas.
You're still doing this one?
I am doing this one.
I'm the bad cop, so I will talk, but in a minute.
So on the enterprise side, we excel at doing this a number of different things. We like to make money. That's our goal in life. We like to make money, but we also like to spend it. And sometimes we don't spend it in ways that we should, but as a business, we do have to make money. Our shareholders expect us to make money. We're very repeatable, reusable. We use commodity hardware everywhere. The same paradigm, a cookie cutter model exists in the enterprise world for us. We do deliver use cases which delight, and sometimes we don't even know we need them. So for instance, everybody, earlier today somebody mentioned how many people are buying an Apple Watch. Few people raised their hand, but if this audience was in California, everybody would be raising their hand twice for 2 Apple Watches. It's just a different crowd. But these are things that we don't even realize we needed an iPhone or a cellular phone until a few years ago, and now everybody has 1 or 2 or maybe 3. But these are items that commercial enterprises bring to the consumer market and say, you need this, even though you don't really realize you do need it. We also have good availability and resiliency. PayPal, for instance, tries to stay up 4 nines available. We're always available 24/7, 365 days a year. We're good at power, efficiency, and resiliency. And of course, we do general purpose distributed computing, not the same model as you guys use, but in that vein, we're very good at doing that.
But there's a few things that aren't that great. So again, I get to be the bad cop here. So there's some biases that both sides have, and this is where we sort of want to start talking with this particular. We're taking away from the BOF a little bit, but it makes more sense for this crowd. HPC, a couple of things. You have lots and lots of discrete problems. It's because you're good at problem acquisition. Only problem is you also have an awful lot of point solutions. If I've figured out, the first thing I did when I started with HPC was look at a product called ParaView. And the first thing I wanted to figure out was which file format I ought to use with it. It supported 130 different file formats, all describing the exact same data. That's ridiculous, right? That's what I mean by point solutions. There's 100 ways to solve 100 problems. That can be a pain. Also, problem acquisition doesn't really lend itself to repeatability, reuse, and centralization as a primary goal. In fact, we've seen a few talks here in the last hour or so where one of the goals would be, hey, wouldn't it be cool if we all got together and agreed on some of these things? We heard one earlier today where they said, one thing that would be that we're waiting for is for some things to sort of fall out and standardize so we know how to back them, right? That's a bias that we see coming directly from the background of HPC. It also tends to be batch-oriented. I had no idea what a code was the first time I attended one of these. People kept talking about codes. I had to pull someone aside and like, what are these things? We call them batch jobs, but we also avoid them like the plague because they're already outdated before we ever start them. It's also proprietary and in some cases even unique systems, which gives you an enormous advantage and puts you very high on things like top 500 and stuff like that. But it makes it extremely difficult to hire someone off the street to be able to program in these types of environments. And then the last one is what I like to call very large data set syndrome. Because you're used to talking in terms of petabytes and exabytes and things like that, you tend to design solutions for petabytes and exabytes and things like that, even when you don't necessarily need to. And it's very hard to break that mindset. On the flip side though, we're not so great at some stuff too. First and foremost, we care so much about reuse, repeatability, and total cost of ownership that those can often, for us, become primary goals independent of the problem we're trying to solve itself. In other words, sometimes we'll forget what the problem was we sat down to try and solve in order to try and reuse a piece of software or a piece of hardware, even when it doesn't make sense to do so. Altruism for us is always secondary to financials. I put in almost, but I'll tell you flat out, it's always secondary. If we stand a chance of not making money on something, even if it's better for the rest of the world, we still won't do it. So it takes things like governments to give us things like national parks. They wouldn't come about if we had companies in charge. Cross-domain knowledge inside of companies is very limited. We tend to hire people specific to a domain. I've listed some domains up here. Those people don't tend to talk, which means that we have entire chunks of the systems that are different. For example, inside of PayPal, we have an entire organization made up of database administrators, systems administrators, network administrators who are responsible 100% for operating PayPal.com. That's all they do. We have another entire set of people who are made up of systems administrators, database administrators, and network administrators who are responsible for running all the computers that actually do things in our office, like this laptop right here. They don't talk. They're not allowed to share information, share the same stuff. We don't hire from each other's teams or anything. We call each other Team A and Team B, and we don't talk. That's an extremely bad waste of resources, but nevertheless, that's some of the things that happen. We have what we call core business syndrome. Even sometimes when a problem makes sense for us to expand into it in order to be able to do something, if someone sits down and says the financials say this isn't part of our core business model, we'll tend to outsource that somewhere else, even when it's not necessarily a good idea to do so, which means a lot of times we use consultants to do things that we probably ought to do inside ourselves, simply because someone said somewhere it didn't meet our core model. And we have this thing, the keep it simple rule, which is one of the first things I learned when I was doing administration, and I've come to detest ever since. Just because you want a problem to be simple doesn't mean that it is. But we will take that rule and beat really complex problems into even harder problems simply because we refuse to acknowledge that they're hard. We're here, though, to ask you guys to talk about what we see as great potential. An elusive one, because we've been talking about it for several years now, but what we think is great. This particular group of people we have assembled here has got a lot of decision makers, and we'd like to see you guys do some things for us. We want to see you cross boundaries, right? We want to see nonprofit and for-profit boundaries start to cross in the types of problems they do. We want to see HP and enterprise start working together more. Because if you'll notice, those lists of biases and excels actually complement one another, right? We want to point out that there's things that we can all recognize. One, strengths and biases. There's probably a sacred cow at you at the table. I had a boss who used to tell me, if you sit down at the poker table and can't spot the patsy, it's you, right? So realize that every time you sit down to a meeting to discuss new requirements, right, you've brought something to the table with you, and that's the 20, 30 years of experience that you've got. But remember, yours isn't the only experience out there, and it may, just recognize that may actually cause a problem sometimes. But also remember this, that creating a legacy, something that you can be proud of, that lasts a long time, it starts off as something disruptive, which a lot of times we're trying to fit things in as easily as possible. But if you think about things that change the world, they didn't start easily, right? Anybody go and see the Alan Turing movie this past year, right? His world was definitely not one based on fitting in easily to the puzzle, right? But nevertheless, all of our lives are changed because a few folks decided they'd stand up and try something new. Together, though, we can create a few things. We have opportunities to leverage blended technologies. I want everybody to try and look for problems that lend themselves to working together and towards communities working towards these ideals. So, back to the boss. So I tell this story. This actually happened to me when I was in graduate school in New Haven. I was there in one of the coldest winters in the 1990s. And a friend of mine was telling me about her parents. Over Christmas break, they had They were going out one day, snow everywhere, and her mom was a ear, nose, throat doctor at Yale Medical School. Her dad was a physics professor in the Yale physics department. The snow is covering the car. Her mom's walking outside with a pitcher full of hot water that she intends to pour on the windshield and walk away. And standing at the door, her father goes, "There is not enough potential thermal energy in that pitcher to melt that snow." To which her mom kind of looked at him, walked out there, poured the water on the thing, melted all the stuff, got in her car and drove off, while her dad sat there going, "What on earth just happened?" There's no way that could have happened. Because we bring to us paradigms that we don't always understand. And in this particular case, all the physics in the world didn't make any difference. In the real world, it worked just fine. So be okay with breaking the rules a little bit. Sometimes the things that look to us like a brick wall, if you take a few steps to the right, there might be a door over here, you just have to knock. And sometimes asking different people for a different point of view from standing up on top of the wall or the side or through that little slit in the door might get you a way of solving a problem we hadn't thought about before.
All right, so we'll talk about a few real-world examples of where HPC and enterprise have come together in a very interesting way. Obviously, smart cities, large data sets of all sorts, from traffic and power usage. The end result of this would be that people in the city will have apps that they can actually alert them about traffic jams for their commutes and or brownouts that are happening or whatever happens that cities can provide you. The next one is actually one that we heard about this morning about IBM and the health, the Watson Health. This is actually quite interesting because IBM also announced something with the weather company about a month ago where IBM was going to be hosting all the weather data from the weather company and allowing a lot of businesses to access that data directly. That opens up a whole new way of businesses to interact with weather data. But in this case, again, it's Apple and Johnson & Johnson and Medtronic allowing IBM to store and have Watson actually analyze all this huge amounts of data coming from potentially the health, the watch, the software on the watches, as well as other mobile units, and it's going to be very fascinating what happens with this.
See, I knew it was going to make noise. It's not supposed to. Sorry, I'm watching something over here in a minute. So another story that happened to me. Last year I was presenting about IoT at a conference in Arizona for a partnership that PayPal has with Arizona State. And the guy that went on before me, his name's Cesar Caracara. He's the guy who sponsored this 1 second every day. I don't know if you've ever heard it. You can search for that app. He's got this idea. Imagine a movie that includes every day of the rest of your life. And so he created this application that you can put on your phone. It'll take 1 second of video every day, and then it'll mash it into videos by year or by month or whatever. Looks like that on your phone. And so in his talk, he was talking about how cool this was and that he has this vision that he wants everyone on Earth to be able to record 1 second of video, to be able to create a lasting movie, essentially, of life on Earth going forward. Now, I'm about to present on IoT, and so he uses this term here, imagine a movie that includes every day of the rest of your life. So this is what I imagined when he talked about this. And remember, I'm going on in 5 minutes, right? I'm right after him. First, I pulled up Wolfram Alpha, and I said, wait a minute. What if I took the world population times 30 frames per second times the average amount of space that 1 second of video at 1080p, which is what my phone can take, which is 5.9 megabytes, times 365.25, that's the number of days in a year. How much is that actually talking about in storage for this thing that he wants me to imagine? If you can tell there, that's actually 461 exabytes a year. And I said, well, that's probably not fair. How about if I look up how many world cell phone subscriptions there are, because not everybody in the world has a cell phone. The number came down a little bit to 430 exabytes a year. So this guy standing up in front of me, he's got a great vision, but he's handed me a problem where I've got to figure out how to manage 450 odd exabytes of data every year, right, at a rate of 13.7 the 14.7 terabytes per second of incoming data in order to be able to bring this vision to light, and never mind worldwide regulatory footprints of taking video from all these countries around the world simultaneously in order to be able to make this giant movie. So I felt like he punted me an HPC problem. The reason I tell you this story, though, is when I say about creating and looking for these types of problems where we can work together to solve things, this is what I saw. This is a mobile app that created an HPC problem because of somebody's vision. That's all it took. Now, I didn't jump out to go and solve this, but I did put this up on the screen next saying, thanks for punting this to the systems administrators of the world, right, to try and figure out how to store this. But what we are saying is that these problems are everywhere. They're commonplace, and if we work together, we can actually conquer that. Right? In fact, when I put this up here, I was expecting a whole bunch of people to kind of freak out, then I remember where I was at. And problem acquisition went fine. A few people went like that. I'm like, okay, we can do it. That wouldn't go over big if I tried to fund that myself. Finally, one thing that's going on right now, this is a great example of a company that is doing nothing but HPC and commercial combined, and this is SpaceX. Now, of course, we are at PayPal a bit partial to SpaceX. Elon Musk did found PayPal along with some other things that you've heard of, like Tesla. But among some things that are interesting about SpaceX, Elon believes full force that reusability is a fundamental way that we're going to revolutionize access to space. He wants to get it down to $500 a pound to lift things into low and medium Earth orbits, which he thinks is completely doable and is nearly 100x better than what we can do today. Right now, in a few minutes, they're about to launch it. That's what I have over here. They will be attempting today, for the first time, to land a first stage rocket onto a platform out in the ocean. Last time they did it, they missed by 10 meters. Today they think they're going to hit it, right? Which will be the first time ever in the history of man that we've managed to land a first stage rocket and recover it, making reusability of the most expensive part of putting things into space a reality for the first time. You see up there that they've done things with their own CFD tooling. They've done tons of stuff by applying enterprise logic about saving money, making money, to some of these HPC problems is going to literally take us a step closer to Mars today. So, think about it. In fact, we have a question for you guys. And that's, how do we do it? So, where we would normally have questions, we're asking you one. What can we do? How do we work together better?